Well, hello everybody. Is my audio working? Okay, good. My audio's working. Okay. Sorry, it's been a little crazy. I ran in here about 5 seconds before the timer went off, and I think I got it working. Let's back it all up. Let's close it all down. Let's see where we're going. Okay. Hello and welcome everybody. Oh wait, I got the chat up in the wrong window. Let me pull it up over here. There we go. Oh, sorry, was the music loud on the stream? Oh, you know what? That's wrong. Just noticed our stream elements. Let's just turn that off. I'll turn it off. I'll fix chat later. But I do see Fox and Valgrind. Yeah, let me know. Sorry if my audio levels are way off, but welcome. It is a binge stream. It's on a weird day because it's been too long and I want to wait till Friday. I've been putting off our launch stream because we have 3.5 is out. So we should celebrate that. And also I've been doing a bunch of malware RE lately. So I want to play with that too. So we got a full day. We got all sorts of good stuff. And that's actually why I started at 4 p.m. today instead of 5, because I got too much stuff. I don't want to get behind. So if y'all are not aware, I think everyone should be aware, we've got 3.5 is released. Very exciting. Lots of new features. So you can see the full list here on the blog. I'm not really going to cover everything, just kind of the highlights. Mod div. Oh, you know what? I got to make sure too. Am I also... Oh, good. It is ultra low latency. Sweet. Okay. Although, here's the thing. I did find out, by the way, that I think my setup can now do 1440 or 4K streams, but I have to turn off ultra low latency. So I'm curious which y'all would prefer, and leave a comment if you're watching this later and you're not in the stream now, because I know there's not a lot of people because we're at a weird time. But definitely let me know via the comments if you would rather have 1440 or 4K or have low latency. Dank, good to see you. Hello. Yeah, so actually, I guess that would be a little biased. People that are here now on the stream might prefer the lower latency because it makes chat way better and more enjoyable. And people that are watching later, they don't care about latency because they're not here. Latency 1080. See, there you go, Rico. But if you're here, your vote counts twice versus people that show up later. So yeah, I think this, and I have the font. Where is it? I can crank the font size up a little bit on Binja. If it's too small, we can make it a little bit larger. Actually, I think this one was okay. I think we decided that one works for viewing things. So there we go. All right, I like the votes for low latency. That sounds good. Oh, I promised I wasn't going to show this off. I'm sorry, Glenn. It slipped. It was an accident, I swear. See, if I could do... Oh, you're saying not ultra... Let's say there's ultra low latency, and I guess there is low latency. So I could do low, and then 1440. That's not a bad compromise, Fox. I might do that. I actually am curious... how long is the delay on each of these? Normal, 15 to 60. That's really annoying. Low is 5 to 15. Yeah, that's still not great, but it's better. If it's actually just 5 seconds, that's fine. Ryan, welcome. Yeah, we got a crew here. I was wondering if anybody's actually going to show up. So I'm surprising y'all. Although I did, in my defense... Oh, let's see if the tweet went out too. I did make sure to queue up the event. Oh, I have 2 pinned tweets. 3 pinned tweets. 4 pinned tweets? Wait. No, those aren't twins. Hold on. Oh, no, it's doing its stupid... Yeah, you have to be logged in to even see it. It's so annoying. I ran this last time too, didn't I? Yeah, it just does those highlights. It just caches some random ones. Okay, good. It went out. We've got the link. So we're good. Ooh, yeah. I mean, as long as I don't talk too fast. I think me and too fast in 2x speed would be even a little crazier. Daniel, welcome. Okay, so let's talk about what we're gonna do today. So first, like I said, we've got 3.5. Hooray. I would love to hear what y'all's favorite new feature is. My guess would probably be, for most people, one of these two, mod div or variable naming. But if you've done any UEFI or UIDF, yeah, UIDF documentation, which I don't even know if that got mentioned, like, except in the like the detailed release notes way below. But yeah, we actually had it before, just in the blog post. So there's a bunch of documentation that we realized, like, why do we write it only in the blogs? And so we move things in here. So the docs are getting better. As a heads up, if you're curious, you can always look at, like for example, here's a good one. If you look right now under the automation developer guide, all right, you can see here's the things that it can give you help with. I wrote docs this morning, which should be, that's a good test. If you go to dev-docs, oh no, it's not even there. Hold on. Plugin command. Oh no, maybe my build didn't go out. Oh no, I specifically did do a build. I forgot. That's right. I pushed that with skip CI. Okay, so that didn't actually go out. You can see it on. You can see it here on my commits. Yeah, you can actually see the docs that I added. But in general, if I hadn't done skip CI when I pushed that commit, the dev builds will actually do not disturb. The dev builds do push to this URL. So you can always view the, even if you're running stable builds, you can always view the new docs, and that same thing goes for API docs as well too. So dev.api will give you any API documentation changes that have happened. So that's the thing. Yeah, anybody else? Oh, Daniel, you know what else? You're gonna like this. UIDF, the documentation got improved on this release, but we've already got, in fact, I think I should go just bug Josh to go push that. He's got a test branch that adds UIDF more places. So it doesn't change the underlying limitations. Like right now, for example, you can only set, like say you've got, where's a variable? None of these are variables. Here's one. So like this variable here, this EAX5 variable here, right now you can only set it using user-informed data flow if you have to switch to medium level IL and you find where it is initialized, and then you can right-click and choose. Did I do it right? It's this one, right? Or is there another one? No, that was it. Set user variable value, right? Like that's the only way to get to it there. However, what's being improved is you can right click on it anywhere and say set user informed value, right? So you can pick whatever variable, and no matter where you've selected that variable, you can, because it's still going to apply it, like the API in the backend is still going to go find where it was initialized because it was set, or where it was set, whatever, right? And it's gonna, in fact, it's actually doing it on the SSA form of it, really, because the SSA ones are all unique, and it will kind of do that for you. But Josh does have that improvement. And in fact, I think it even adds support for high level IL. Again, behind the scenes, it's actually going to medium level IL, SSA, and doing all that stuff. But like, you can just pick a variable and be like, yeah, please set that. So I should bug Josh. I'll DM him right now. All right, let me go ask him. We'll see what he says. He's also in the office. I could go over and walk up, but yeah, because I agree, Daniel. I think that would make it makes the feature more discoverable. Because one of the problems we have right now is it's really hard to even know about that. Like unless you happen to click on medium level IL on a variable and right click and choose, set user variable value or whatever. It's not even the. Where'd it go? There it is. Set user variable value. Nobody would ever find that. Or if they read the blog, or now that they've, we did at least have the docs, but that's going to be getting a lot better. So that is super nice. UEFI support. I'm actually going to be working a little bit more on that. I've got some other ideas on that. I know that's a great suggestion, Daniel. We should make that note. Killer features page. Yeah, there's a whole bunch of things that that I always like take for granted. In fact, like even what I'm doing right now, right, where I'm in a high level IL, just like scrolling, the fact that I can do this, like no other tool even does that. You can't just look through high-level IL or decompilation or pseudo-C or whatever they call it. Yeah, UIDF is super powerful. The value set analysis, I know. Um, yeah, we need to do better killer features right up. We're better engineers than we are marketers. I think that's for sure. So, um, hey Scott, welcome. Uh, yeah, so we gotta get that stuff out. Bunch of other little things. Debugger supports time travel. We've shown that off here. And then you'll notice like the experimental section of the blog, like we've got features that are experimental, and then features like image file set is no longer considered experimental. So sometimes we'll have a feature where it's not quite done, but we want to get it out there. We want to, sometimes we'll make it disabled by default, or we just kind of warn people it's still considered experimental, and then we'll push it out. Like components, for example, we thought would be enabled by default in this release, and it still just wasn't quite ready. The performance is not good enough yet, and so that's still experimental. But we are optimistic that that should be enabled by default actually pretty soon on dev, hopefully, and then it will be shipping in the next release. So, oh, that's awesome to hear, Daniel. Because you know what, we ran into a bunch. We ran into just a couple during testing, and then we just started really aggressively looking. So that's super glad to hear it. That we were actually, in fact, I was even more of a pessimist. I was like, oh, most of these leaks only impact people if they like do a very particular workflow. Like if you had to open a file and rebase it in the debugger, and then close the tab, and then like there was a certain order, and then not close Binja, but then open another file. And so there were a few of the leaks that were like that. But we definitely, I think, fixed some ones that may have been impacting more people. So that's great to hear. Oh, look, I can even click a little heart. Look at that. So interesting. Plugins. Huh. Well, I'm glad that you're seeing better memory utilization. What else? Yeah, like I said, I think that kind of covers most of this stuff. I still really like the auto renaming. I've seen it really improve. You notice the font, by the way, it shifts a little bit because there was a very subtle font change too. So you can't quite align things exactly the same. But there's some very subtle font stuff that I think most people won't notice. The main thing is those variable names changed, which make things much more readable. So, oh yeah, that's interesting. I didn't notice that. Oh, that's cool. That's so funny. I literally learned that just now. Check out get proc address for H module. If you name the variable the same name as the parameter, it actually doesn't show you the parameter. That's clever. So it's actually a little more concise. It's a little, if it happens to be the same name. But if, for example, it's like a string constant, like here, and it keeps the parameter name and the value passed, or the argument and the parameter or whatever, that's nifty. Cool. Well, that's good to know. Let me make a note, by the way. Low latency 1440. We're gonna try that next time. We'll do that. We'll do that next week. All right. Yeah. So I think that's cool. If there's anything else that you were particularly excited about, let me know. Yeah. The mod div stuff, that was fun. Did a bunch of testing on that. Oh, actually, in fact, if you read the details, ARMv7, also I can't figure out why the syntax highlighting goes weird on that one. I did that, I noticed. ARMv7 mod div support is kind of broken, but it's actually a lifting bug, which I think is getting either already fixed soon or it was on a test branch. There were a couple features that we had like and test branches right before the release, and we didn't want to have to redo all of our testing and or make last minute changes. So they're going to be going on dev soon. So I think that's another one where we've actually got a bunch of improvements on the mod div that'll be on dev. So, all right, let's go actually play with Binja. Let's do some real stuff. So I actually went to LabsCon last week, which was good times. It was fun because I'm not really a malware reverser, and I like hanging out with malware reversers and learning from them and seeing what they're doing. So there was a lot of interesting stuff. Oh, this is last year. Yeah, that's funny. I just realized. I was like, Dimitri wasn't at LabsCon this time. Oh, that's interesting. I wonder if they're gonna. Yeah, I guess they just didn't post any tweets at all this year. But it was a good time. Yeah, look, you can see a little Vector 35 sponsorship. Although in hindsight, we're supposed to use you're supposed to tell them to use the Binja logo, so I think we forgot that. But cool event. Lots of really smart folks. It's a small kind of little event. Saw Sergey and Sean both from OA Labs, which was fun. Those are good folks. I know a couple of y'all watch that stream as well. And so yeah, this is okay. So this is yeah. So I literally, as a part of like the sponsoring, we had like a demo slot where I could show off some Binja features, and I was like, oh no, I should RE some Windows malware. So I did. But I specifically um, got like just I literally went like Googling for like just give me some malware kind of type things, and I found a couple of different samples of various viruses, Petya, NotPetya, Zeus, and so then like I was looking through different write-ups and different explanations of issues. Um, oh, there is. I think there's also a new feature where you can turn on. You know what? I actually haven't tried that. Let me try this. Feature map. I think the feature map has a one-dimensional mode version. Or maybe that's only on a test branch still. I thought that was live. But there's another change coming where you can actually, if you don't like the 2D grid, which I generally do, I mean, because you can choose how wide you want it. You can see this is not a huge file. And so like the pixels are kind of large and you make it bigger, but some of like really large files, you'll get more granularity. Actually, you see it's interesting, those pointers that are all shown here in this region all disappear when you make it narrower. That's kind of fun. Yeah, Cantor Dust as a whole, probably not. Actually, BinViz, I think, is better than Cantor Dust at this point. Is it BinViz I'm thinking of? No, I'm thinking of a different one. What's the other one? I can think of the logo in my head. There's another tool that actually has better stuff than Cantor Dust, or it's not binary viewer. Velis. Velis I think is the best. Yeah, this is my favorite. Oh, it's archived now. But yeah, this was a good one. Is there nothing? I guess maybe then this one is a newer than Velis. So this one might actually be. It looks, or is it literally just a fork? No, it's a different UI. But anyways. Hello, RQ Hertz. How's it going? Speaking of Vivisect, Vizzy was actually at LabsCon. I saw him, hung out with him a lot. Vizzy's a good guy. If you're a fan of Vivisect, if you actually haven't heard of it, Vivisect has been around quite a long time. I should probably not just search for that word. Yeah, as that reverse engineering. But I know like Atlas and Vivisect are two of the main like contributors. Yeah, actually Atlas is showing up higher than Vizzy even. To Vivisect, but I haven't seen their visualization stuff. That's neat. I'll have to play with that later. It's definitely one of those like once you get hooked on it and you know a tool really well, you'll just like drag it with you to your dying days because it's like you just are so quick with it and you know it. And so there's a lot of I know there's definitely some people that are really used to it, but oh yeah, Vertex is vstruct. Nice. Yes, I agree, Ryan. Good technology, good people, good crew. And I met a couple other, another guy from Vertex was out there too that I think I met for the first time. Sometimes it's better about remembering that stuff. So let's talk about this bit of malware. So like I found this malware. I started reading it right up a little bit, and they're like, oh, it had like this encrypted string table, and you can kind of even see if you just poke around here, like here, like this sure, there we go, right? This sure looks like some encrypted string table. So we see these like gaps with like non-printable or mostly nulls, and then like runs of like some sort of XOR or shifting or something's going on because this is like ASCII but not. And then, yeah, like I said, there was those pointers you could see here. So you can actually see this whole pointer thing here. Well, what is this a pointer to? Oh, it's a pointer into this table, right? So we've got some like section here where there's a bunch of encrypted pointers. And then we've got this like up top, we've got these pointers into it. So let's go to the beginning of this. Actually, we can just kind of hit it in the UI, I think right here. Yeah, okay, so here's real string, real string, real string, and then null, and then it gets aligned. And okay, so we've got here. So let's see what we've got. We've got also a couple of strings. Oh no, there's more strings, more real strings, more real strings. There we go. Is that the end of it? No. That's a buffer. That's a pointer to a function pointer going on there. Okay, so don't know what this is. Curious, but then here, okay, here, yeah. So this is one of these. So this is a pointer into what's probably like this encrypted region of encrypted strings. Okay, so let's look. We've got a pointer here. And then we've got, before, you see there's actually two cross-references. So these, by the way, this void star pointers, these are our new heuristic pointer analysis. So actually this was another new feature where we just say, hey, it looks like this is a pointer to something else. So we're going to highlight that and show it to you, which is nicer that it does it for you automatically. So that's another new 3.5 feature. But this is probably the base thing right here though, right? Because we got these two, one of these or both of these are the base. And we can see 8 Bravo 6, 92 Bravo. 8 Bravo 6, 92 Bravo, and then there's one other one. Okay, so yeah, like these both have cross references. So this thing and this pointer maybe is like a structure, right? Because then we have another one. We have this other word value and then a word value and then another pointer. Hey, username, welcome. So sometimes confidence is actually, I believe confidence here is because see how this is gray? That means low confidence. I don't remember the exact number. And I think you can extract confidence from the type system. But actually, if I hit one of these things and I make it void, you'll notice that that one is yellow now. So you do see confidence if it's just very low confidence. There's not like a lot of granularity visibly, but there is some, and it's specifically when something is grayed out. So if you see like a gray out, and that's also why even like if you're just in, like let me split, unsync, and just go over here somewhere. Oh, I thought I unsynced. Hold on, go back. Unsync. Now go over here. So like this type information, right? Low confidence. It's int32t because that's just the default type. But if I tell it, no, really, that variable is indeed an int32t, now it goes yellow. In fact, also you notice the return address or the return type changed. So that's one way that you see confidence in there. Even assignments, like this entire operation is like, is this dead code eliminated or not? Like it's kind of like grayed out because you might not need it, but you might want it there. So yeah. Is that documented anywhere? That is a fantastic question. I don't know. It's going on my list though of things to look up after the stream. I don't know if it is. Let's look. Let's look. Oh my gosh, that's embarrassing. No, it's literally documented, like not even anywhere. It belongs at a minimum under this important concepts, and it also belongs somewhere in just the regular user manual. I'm not sure where I would put that. That is a great question. I'm glad you asked that. Thank you for mentioning that, Daniel. Yeah, so that is totally undocumented, and that's not great. So in fact, you notice I can undo, and the color changed right back there. So yeah. All right, so these are heuristic pointers. They're like, it's probably a pointer because it looks like a pointer, but I don't see it used necessarily as a pointer. Well, actually, in this case, I do see it used as a pointer. So this one actually, I would say probably could be higher confidence, right? But this one, on the other hand, I don't see it used as a pointer. In fact, actually, I wonder, let's do this. I'm curious. Current, I know it's bv.get data var at here. Okay, dot type. what is the, no, it is, yeah, v.type.confidence. Yeah, okay, so this is, I thought that was full confidence on this one. That doesn't make any sense. Hold on, let's see here. Oh, no, okay. There's a difference. So that's the thing is you can have confidence apply to like different components of it. So I think I might be querying the wrong thing, but let me see 1 second. Let's do V2 or V0 is the first one. This one we do have code cross-references, right? So we see it being used as a, can I say again how nice it is to always have cross-references on the screen, by the way? It's one of those other UI differences that we do different. We do so type, I think I'm doing something wrong here because well, actually, no, that's not true. Let's do this to really see it. Let's change that. And now we see it's not gray. So now if we, it should be the same variable. Yeah. That type.confidence. I don't have it backwards, right? No, it's, yeah, 255 is supposed to be max confidence. Something isn't right here though, because this void, but I think it might be the, oh, I think it's the pointer type. Okay, hold on. Yeah, so again, because you can have confidence on multiple parts of this. So let's go v.type or v.type. Because yeah, children, right? So you can have, yeah, there we go, right? See, exactly. But now if I do v0, still the same. That void is 0% confidence, but I thought it was this one. Hold on, let me get another copy of v0 just in case I just have a stale reference. Yes, right? You see that? So that's the difference is when I actually set this one to be a void class, you can actually see that show up there on the, and again, this is because you have confidence like at different levels of the type, which actually can make, you know, the code around it a little bit awkward, but yeah. Yeah, okay, I know Friday. We're doing an early stream this week, so we actually, yesterday at one point I thought we were gonna have power out in the office this Friday. So now we might have it back, but I just wasn't sure about that. So, and also it's just been too long. I don't want to wait till Friday. So what was it we needed IPython console from the plugin store? I mean, I've already got all the features that I want in IPython, like Control R, reverse search. I think most of the stuff that I like in IPython I get from here. Tab completion, right? I mean, it is a little bit better, but you know what? That's a good question. So I turn tooltips off, so I have to hold control. Yeah, actually, you know what? So a lot of things, like if I hover over a function or, let me see, let's go back. Actually, let's open a separate file because I just want to have something else to play around with here with that. Okay, so if I hover over decompilation of like an IL instruction, for example, you do get like extra information, like variables have stack frame offs. So this is other stuff that can, and this should be like the code for that function. Yeah, so you can get other things like that. So putting confidence in the variable hover, yeah, I would. But again, it's a little bit tricky because the confidence can have like, is it confidence that it's a pointer, confidence that it's a void, like there's different components of it. Is the name, or how confident are we of the name? I think even symbols can have confidence. Is that true? I think it is. Let's try something. Let's get into actual code. Current function.name. That symbol, not confidence. Maybe not. Yeah, I still suspect there might be. Yeah, maybe there's not. Maybe symbols don't have. Actually, I'm curious about that. Go to the notes. Do symbols have confidence? Not totally positive on that. Exactly. Okay, it was like a week or two before, and then we were swamped with the release, and then we were just ready to take a break, and then I was out all last week, so that's why it's been too long. Oh, confidence of analysis passes. Yeah, that's a whole separate thing too about how that's exposed. So okay, so let's go back to our malware and our string obfuscations. Right. So we've got this. So like this is a pointer. In fact, actually, we know it's a pointer to this encrypted buffer. So we could actually hit Y and change this instead of a void star like a char star. Um, and this is not actually ASCII printable. So the UI is like, I don't care what you think it is. I don't see it as a char star. So that's fine. Um, but let's go look at the cross references too. So just even like um, without even looking at the function where this code is used, just looking at the summary of the cross references, for example, this first one here, we can see it used in this like XOR sequence, right? So that cross references. So we've got our 52 cross reference. This is like our base. Yeah, so this is like a base pointer. So this whole thing is being treated as a pointer in this first one. And then here in the second one, we've got like this whole like XOR chain that is annoying, but we can see we're actually, oh, let's see, where did it go? Now, I was hoping I could do this just through there, but I'm not. I'm actually going to hit this up in the UI. Actually, you know what? Let's do this. Let's split it, and then let's turn off syncing, and then let's go over here. Yeah, so now we can see our data as we see the decompilation side by side, and we can shrink back our cross references. So, oh, another modifier key for hover. Yeah, there's a lot more we could put in there. Yeah, that's not bad. Like like I said, I already have tooltips turned off, so I have to hold the control key to get any hover information. Having like a control shift or something, or a shift modifier for hover or alt or whatever. Probably not alt because cross-platform and all that stuff. But yeah, having another modifier combo for more data is a good idea. But the downside is that it's not really discoverable, so people will probably be less likely to find it. So okay, so we've got our base here. We've got this value here, this 554, and we can see and then we've got a pointer. Is our pointer being loaded? Oh, also, let's look at this. So we've also got this. So here's, oh, the other way to look at this would be, let's just eyeball these, hex 31 and hex 13. Let's look back over here. This buffer looks like it's this long, right? Like you can see this null byte, like it already is this encrypted buffer probably, or like let's look about like 31 bytes, hex 31, and see what we get. Like that's just in the middle of something. So like that 13 is almost certainly a length, right? So let's come back over here. And actually while we're at this, look, let's like this whole thing is almost certainly a structure because we've got this, and this, and then we've got that repeated, that same pattern. It's 16-bit, 16-bit, and then a pointer, and then we've got another one. And we can see these are all null here. So it probably starts here. This is also the base. So yeah, let's just hit S on that, right? So I've selected them all. I've hit S, and we're going to call this like a crypt entry or something. Or actually, let's name the struct. Let's call this crypt entry. And you notice it already has our field 4, which is our, like, you know, so this is the encrypted buffer. And then, what do we say, that 13? Yeah, the 13 was the length. So let's hit this. And actually, at this point, one thing you can do, by the way, is you can right click and choose create all members for structure, or just hit it and hit S, like if you're already in the view of it. And it's just like, yeah, I'm going to create all that stuff. And these are not right. Interesting. Yeah, that's not right. Let's undo that. What did it do that for? Oh, because it sees it as a D word access. Yeah, I didn't list it, right? So it because it loads them as a D word. Um, but then I think it just immediately casts them. It's not actually, yeah, word dot w. Okay, so I'm just gonna hit 2 instead on that. And on this one, I'm gonna hit 2 instead on that. And then the second one we decided, yeah, 13, that's a length. Um, and actually we're gonna make that an, actually, let's make that an unsigned int. All right, so that's our len. And then this, we'd have to look a little bit more closely at. Let's see, so field 0, look at this, here we go. Actually, I hit 2 to make it a word, but we see here it's being accessed .b as a byte. So let's go hit 1 on that instead, and we'll change it to a char. And then, yeah, we got some padding in here, but that makes sense. It's the structure is always going to be at least, even aligned, unless it's, yeah, I guess yeah, if it's packed, it could be packed tighter or bigger, but it looks like that's unused at least. I don't see any references to it, and we know this is being accessed as a byte. So this is this field 0. It's being loaded. The pointer. Okay, so this is just the base of the pointer. Let's see what else. And then our encrypt, yeah, we can actually see the encrypted buffer is being referenced at this EBX, and so that's looking like a or sorry, EDX. EDX is loaded from EBX. Oh, and EBX is definitely a counter, right? So that one's definitely like I. So we've got our little loop, and we're iterating over it each time, and then this is just going to be another copy of it here. Because it's just gonna, so it's just J or counter or whatever we want to call it. And then arg2, okay, so this argument, this is going to be, it's being written to as a pointer, so we know this is probably like the destination buffer, like it's being decrypted. So, right, so that's like the decrypt buffer, and it's not going to be an int32, it's going to be a char star. Right? Oh, and it's starting to look a lot cleaner here. And this arg1, let's see, how does this get used? So this, right here, right? So see how we're treating the base? Okay, so we've actually got a whole bunch of these things in a row. Let's fix that up. Let's make an array of these things. And the nice thing is in the UI, I can easily see this kind of pattern here. And then just scroll, oh wait, hold on, sub, that's different. So this is, there we go. You notice so this is where the string pointers end. Yeah, so this is the very end right here. This offset here, or I guess this address here. So let's, this is a cheeky way to do this. End equals here, right? And then let's go back up to the start of this in the UI. I could have also just hit escape a couple times. And here we go. This is, yeah, crypt entry. Here we go. So this is our start. So hex end minus here, divided by quiz. How big was the structure? 8 bytes structure, right? Divided by 8. Oh, yes, please integer. Okay, 195. So it's 195 or 194 if I'm off by 1. I don't really. So let's actually hit this, and we're going to make this an array of 0x195. All right, and so now we see we've got our structure. It's an array of these crypt entries. We're going to call this like encrypted table or something like that, I guess. Whatever, it's like this whole structure here that's been referenced. And now like this is getting pretty clean here. So we still don't know what, oh yeah, our first one, yeah, so let's look at this. That first argument, then this is the important bit right here, right? So this first argument gets copied into ESI, and then that's used as an index. It's the number of elements it's like this index value here into our array. So like this is like string ID or something. Is this string ID being copied in, it's being our lookup, and then this field 0. Oh, right. We don't know what that is yet, do we? This field 0 actually gets, Oh, this is actually a little annoying here because it's reusing the register here, but this is actually I need to split this here. Is that right? Yeah, I think I did something wrong here on my markup because I think this one, yeah, this is actually, yeah, this one, I did something wrong here. Let me look at this. Yeah, because I think it's reusing CL to hold, right, so it's doing this XORs here, and then it's writing that back out into our destination. So I think we're actually conflating the string ID that is the argument passed in with the string ID that is, oh, yeah. Because, yeah, I don't want it to treat it as a float. I don't want float 8.0. I just want an integer one. So floor division or just like integer division. Just it's only the integer portion. Because otherwise division by default can be floating point. Like even if I did 8.8, it's still good. Oh no, that's right. It does integer. So I was just off by 1. Yeah, 194 is not. Oh, it's 195. Oh, it is probably 194. That was why. That one would have worked. No, that was still off. Oh. What did I do wrong? I don't know what I did wrong. It probably is. I just did some math wrong with my. Yeah, that's obviously not divisible by 8. It would have to be, right, 0 or 8 would be the only ones that would divisible by 8. So 195. So it's probably just, that's weird. What am I doing? Yeah, I don't know what it. So anyway, it doesn't really matter a whole lot. I was off in my calculations, and that was actually a bad choice. I shouldn't have done that. I should have really figured out like why my structure count was off. Actually, here, now that I've set the size, I could probably just scroll down and get a good sense. 194. Oh, well, it's 1, 2, 3, 4. No, 5, 6, 7, 8. It's 8 bytes. So, yeah, that's right. So it is 194, not 195. But why is that not divisible by OX194 is not divisible by 8? Right? I must have had the wrong OX194 times 8. Oh, right. It's not 194 is divisible by 8. It's the offset from the end to the beginning. That's what I was doing wrong. Right? By the way, let's just go to the beginning here that way, which is a nice little way to get back here. Yeah, so this we had the wrong count on. It is 194. Oops. All right, so this XOR loop here is XORing. What do we got? We start with we not our that first byte at the base of this. Yeah, so the index. So this is our index multiplied by or divide. Actually, it's not right shift, right? So that's divide by 8. So it's not actually string ID. It's offset, I guess. So it'll be like 1. It'll be 1, 8, whatever. So it's telling us. It's just telling us the index into the table. Or is it? No, it's left shifting. I'm reading it wrong. It is an index, right? It's times 8, right? So it's a count. It's just telling us like this value here, 0, 1, whatever. And then this first one, okay, so this is a key. This is like a XOR key, right? So the XOR key is being read out here. And you notice this is kind of ambiguous. Is it reading the base of the pointer? Is it reading this value? Like it's all the same, right? They're all at the same offset. So in this case, we're actually reading out that XOR key. We're gonna not that. We're gonna XOR that with the byte that we're reading from our encrypted buffer. And then we're going to XOR that with the counter itself, like so the index. So like however long the string is, In this case, there's hex 13 values. So now we have everything we need to write a decryptor. So let's write a new, oh no, let's see here. Can I remember how to do this? All right, we're gonna make a new snippet, Zeus, and we're going to open an editor. Except that's not what I want. I want to do this. Let me see here. What if, I think if I do, oops. I think if I go to binary ninja snippets, okay. I think if I just do this, open with, and I make VS Code the default type for this file. Yes, please. Oops. Perfect. I don't know what I just did, but I don't think I need that. Okay, so let's, don't save that. Whatever I changed, I don't want it. All right. And so now, oh, let's just do a little bit of Zeus decryptor. So this is, yeah, a relatively new feature in the snippet editor. If you haven't seen that before. Stuff here. You can open an external editor. And so if I don't want to use, oh, no. Oh, you know what? I bet the file association needs to be reloaded. That's fine. We'll relive engine. I want to make sure that works. Restart and reopen files. Let's close down everything else that I don't want open. Let me bring chat up again. Make sure I'm not missing stuff. Got quiet on me. Y'all still here? Yeah, let's save our database, please. It's so rare. I'm actually reversing and making structures and doing a real RE. Okay, so snippet editor. Open in editor. Oh, that didn't do what I wanted. Yay, thanks Daniel for letting me know. Okay, so sure, you can go ahead and update. Oh, that was fast. All right, open plugin binary ninja plugins. No, snippets is what I wanted, right? Snippets. Oops. What to do? Yep, binary ninja. Okay, try again. Open Zeus. No, why you do? I said open with VS Code, always used for this type of file, open. Is Ubuntu just, oh, that's what that was. Okay. All right, I'm not gonna let you do, like, you can figure out the length of my password. Oh no. All right, never mind, that makes sense. So now, if I double click it, I should get VS Code, which I do. And so now, if I go back and ask snippets, cool. All right, so let's get our plugin here. So, I need to put neovim. Do I want to do that? Yeah, let's do that now. Oh, I already have it installed. What? No, it's not using, I know why. Trust. Yes, please. Please. Sure. I don't know what that was. Thank you, Daniel. Yep, you were correct. You got it. All right. Yay, I can vim my hotkeys. All right, so let's think about this. What are we going to do? We are going to first let's figure out the start of our buffer. All right. The way that I was going to do this is go that. There we go. So this is the start of our buffer. And and end was, let's go to that, plus fun trick, you can do 8 times OX194. Do math right there on the go-to dialog. Okay, so this is, oh, wait a minute, hold on. Oh, I chose 194. No. It is 195. There's one more entry there. You know what? This is why we check things. Da, 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 da. There are 195 of you. Cool. And so now, go. Actually, can you do? You can do that. Plus, OX195 times 8. Right? Yeah. Okay. Actually, I guess I could just do it that way too. We know there's OX195. So end equals start plus OX195 times 8. This font is a little small. Let's see about making that a little bigger. Actually, wait, I think I can just Control Shift plus, right? Yes. One of the few nice things about Electron. All right, so this should be the thing we're gonna loop over. So we're gonna wow, start while offset is less than end. Let's loop over. Okay, so first let's read out what do we got? We've got the key, the length, and the pointer itself, right? So key is equal to, there's a new, not new, it's not that new of an API, but one that I haven't used as much. So let's, like if I want to read out this key value here, I can just use bv.read, but, oops, yeah, that's going to give me a byte array, and I could then like struct unpack, or I could, there's other things I could do with that, but I can actually bv.read int. And you'll see that read takes an address, a size, and whether it's signed. So the address is here, the size is 1, and the sign is equal to false. It is not signed. Right. So that'll actually get me the the value here, right? Except this is going to be offset. Okay, and so this is going to be that's just 1. The length is equal to bv.read int offset plus 2, and it's going to be a word. It's 2 bytes, and it is presumably unsigned. All right, and now we're going to go pointer is equal to bv.read int offset plus 4, 4 sign equals false, all unsigned. And now let's see what else. I guess we're just going to loop over it and do that kind of XOR. So let's see. Let's first just log it. So output or decrypt is equal to an empty string. And now for buff offset. Sure, buff offset in range length. And now we're going to read in, so the byte or the byte input is equal to bv dot, we're going to read a byte at a time, so read int, and we're going to read from pointer plus buff offset, right? We're going to read in 1 byte, and sign is equal to false. We're going to treat it as unsigned for our purposes, yeah, because we're going to treat it, we're going to do like bit mask stuff on it, so unsigned. Okay. All right, pointer plus buff offset. All right, now, so we were first we were the nice thing about the XOR is that we can do it in any order too. Also, I'm a little slow. Sorry, Mr. Oh, sure. Yeah, we could absolutely do this with the object. In fact, okay, so there's a couple of ways we could do this. One is we can literally, so although the only downside is we need to know when to stop. And one thing that's interesting about this, if we just scroll through this struct real quick, I think yeah, there's a couple times where there's like empty entries. Normally I would just say like go until you hit like a invalid pointer, but there's just a couple of entries where like there's empty entries in the table, and so you can't actually do that. So you need to have some way to know when your script should end. And I'm lazy, and I just in the UI looked at it and yeah, hard coded that or counted the number of entries or did that. I could have also just selected, right, a whole like all of the data, and then have my snippet work over that because there's current selection, right? So that's one way to do it. And we've got a start and an end address. So I could have rewritten this plugin, and because it's snippets, the current selection is literally available in here. I can do start is actually equal to current. Could have start is equal to current selections of 0, and end is equal to current selections of 1, and that would have done the exact same thing if I first in the UI selected all this stuff. But that would be annoying because it's so big and I have to scroll a bunch and then shift click and whatever. But yeah, the start I could have absolutely calculated. And in fact, if I wanted to do, so like let's do that. So let's see. One way to do this would be to do get cross references to crypt entry. So actually, it's a good question. What is the type ref, I assume? Let's see. Get all types referenced, get code ref for type. There we go. So this is the API we want. I don't think I've ever used this one before. Get code ref for type, and you give the type name. Easy peasy. pv.get code refs for type crypt entry. Actually, that's not what I expected. Oops, wrong one. Get road refs for type objects that references a qualified name. Yeah, that should be right. Or maybe it's maybe it's the name of the table, not the type. So I probably encrypted table. The other way I could do this, well, the way I know it'll work, I'm surprised. I don't know why. Oh, because it's not a code reference. Right. I'm not looking for a code reference. I'm looking for a data reference. Hold on. You just do this. I don't know if that API exists. But I can just do bv.get symbol by raw name encrypted table, right? Dot offset or dot start or address or something. I don't know. Start address, probably address. Yeah, right. So that would be the other way to do it. And that should be the same as my start. So let's verify that. 41A550. Right? Yeah. So that's the other way we could have done that. Oh yeah, structured data view is a whole thing too. And that structured data view is another way to like pull out the things that I did here. Instead of just reading bytes and specifying that, I could have read out and said like, hey, at this offset, assuming it is a crypt entry, give me the XOR key, and it would have literally just returned me the XOR key. So that's another cool API that I could have used too. So okay, so first we're going to read that value. Let's go back and double check what that encryption loop do. So we XOR it with, so we not it, which is really nice because that's just XOR with FF. So we're going to do is equal to the byte XOR OXFF XORed with, what else we got? Oh, the key. Okay, so the key and then the counter, the index, right, that we're into. So that should just be the key XOR with buff offset, right? So buff offset, yeah, right? Okay. And then output plus, or sorry, decrypt plus equals B, and it should hopefully, well, we'll see, because it could be decrypting like other buffers, not that. And now after that loop is done, let's just do log info found a string decrypt. Okay, so let's just see if this works. We're gonna save that, and because we've already got this in snippets and we can just save it here, we can actually rerun run Zeus decryptor from from the plugin manager, and it should, oh, I've got errors, I think. Length is not defined. Wait, did anybody get it for me? I don't know. If we go into too much detail, especially in APIs, there's so many killer features that we would never, never. Oh, len. Oh, that's a reserved word. I can't use that. Or is a length? Which one is it? Len is the reserved word. Yeah, not length. So length. Yeah, let's save that. Can only concatenate stir, not int to stir. Oh, right. I'm gonna need to actually convert this. So let's do like byte. Like just treat that as a byte array, and then I think we can make the whole thing as a byte array, which will coerce to a string, and maybe let's try that. Bytes. Sure. Oh no, I know what I wanted. It's a single one. Order chur. I always get it backwards. Okay, chur. So just in case you're not aware, ord and chur are like take an integer and then make it an ASCII character essentially, but one's the opposite of the other. So ord given an ASCII character will give you the integer value of it. It can again struct pack and unpack, and there's a lot of ways to do that. So I think I want chur here. Yeah, let's try that. Oh, it's doing a thing. Something's not quite right here. Okay, so I messed something up. Oh, yeah, well, I see what the problem is. That would definitely be a problem. And I'm gonna have to restart now because I don't think there's a cancel. No, there should be a cancel snippet. I thought there were background tasks. Cancel. I'm just gonna restart because it's faster. I didn't actually increment my offset, so I'm just gonna loop there forever. How many people got that one? Let's see here. Right, and now offset plus equals 8. Right, so let's go to the next kind of entry. We could also just have made this a snippet that worked on here and only did it one at a time manually, and then we could have hit it and kind of looked at it. But I mean, that decryption was definitely working. So let's also just do this. Let's actually write the value to the decrypted buffer, because then all cross references in that list will get cleaned up. So let's do bv.write. Well, actually, yeah, we can do it right in here. bv.write. In the same place, we're going to do pointer plus buff offset, but we're going to write in chur of b, right? Or no, that does take a byte array, so we're going to have to do bytes. I think that does it. Right, that. Then we're gonna add to our string. We're gonna log it out. But this will actually write it in place. So if this works, what'll happen is all these strings should get decrypted. Couldn't read one. Oh yeah, that's not a. That's a bogus. Oh, but look. Aha, partially. Okay, so some of these. That one's not like a full string. Oh. Is it this one here? One of these might have had. Yeah, so we're definitely decrypting some of these strings, but this one maybe messed up. What I messed up? Hold on. What did I miss? So let's see. Hold on. Key, length, and pointer are all reset. Oh, I should probably. Yeah. Okay, so let's see. So I want to see if this is a real pointer into the virtual memory. This is a nice API. So I had to look this up because the first time I wrote this, I looked into sections and segments. But there's an API is valid pointer offset or something like that. So let's go double check that. Let's just look for valid offset maybe. Get next valid is valid offset. Yeah, is valid offset. And you give an address and it, yes or no. Okay, so if not is valid offset pointer, then we just are going to offset plus equals 8. Or actually, no, if it is a valid pointer, and just do all this stuff. Okay, so if it's valid, do that. Otherwise, skip it. Yeah, let's do that. Although, you know, we actually have to kind of undo our last. This is very nice, by the way. This whole snippet is done in one undo transaction. So I can just undo, and you'll notice all the strings went back. And now I can rerun it, which is nice. So again, we crashed because of some other bug, but I really like that it did that. Okay, so hold on. A2 couldn't read 1 byte from address. So which part is it bugging on? Buff pointer plus offset. Hold on. Pointer and buff offset should be in range of length. That looks right to me. I've done something wrong. I've been bouncing around, I know, so it's hard to follow the screen. So let me see here. Found a string. We can also see how many strings we wrote. Oh, we actually wrote a bunch more. Okay. Oh yeah, you can actually see that. Yeah, so some of these are actually like data structures or other things that got decrypted. They're not just, maybe they're, yeah. Oh yeah, so okay. These strings are generally decrypted. That's great. Actually, let's go back out to here. And you know what? I'm going to modify this to undo that. Let's go back and let's decrypted, spell right, decrypted string at hex pointer. Okay. All right, so let's do that. Oh, what did I do? Hex of pointer. That's fine. Did I? Oh, some key is stuck or something's going on. What am I doing? I'm just. Oh. That I did make a typo. Look at that. Deleted one of the spaces. Is valid offset is not defined. Did I typo the API? Oh, BV dot is valid offset. Right. It has to exist off of that. Yep. All right. So do it again. All right, close. Okay, I saw a bunch of stuff flash by. So yeah, there we go. Okay, so this is our last valid one. And let's go back to that entry. But no, wait a minute, that one worked fine. BVF0. Oh, okay, hold on. So this one crashed somewhere in the middle. Oh, no, the extra key's fine. Lang, okay, this looks fine. Why would? Oh, that's not a valid buffer. Yeah, this is not a valid buffer. But is that the one that crashed, or is it the one above it? Let's see. Bytes must be in range. I'm XORing all byte-based values. So I crashed somewhere in the middle of this thing. No, hold on. There's a bunch more after that all got done. Did the log? I wonder if the log buffering got messed up because it's... What? Yeah, these are not decrypted. Why is it somehow... Okay, let's undo. No, let's redo. Yeah, let's copy this offset. Where is this? Okay, so let's undo. Let's go back there. Also, that is weird. What is this supposed to be? Oh, I wonder if it can decrypt things in other memory ranges or something, or if this was binary was rebased or something. That's weird. That's not a valid. So let's just verify that just for kicks. bv.is valid for offset. Yeah, that's false. So that won't be going. So why? I still am not seeing what's causing this to crash. Bytes was okay, so the bytes thing is failing, which means this value that doesn't make any sense. I don't understand why it's crashing. I really do like that. Okay, let's go look at the. All right, how in the world am I getting 165 if I'm XORing? Okay. Noisy. Okay. Oh, okay. No. That makes sense. Hold on. Okay, so it's is the key. Okay, so yeah, we've got all right, let's write everything out. So we've got B, we've got key, and we've got oh, I see what I'm doing wrong. Right, the length. If the string itself is longer than 256 bytes. Did anybody catch that? Oh, okay. All right. I retain my dignity. Okay, so let's actually first with XOR that. Now which and is it? Is it single and? I can never remember. Okay, so if I have 1 0 1 and OXFF. Okay, so single and. Right, so see what I'm doing here is I'm basically masking off just the lower, because it has to be a byte in size. I only want to write back that 1 byte, and we can confirm this. Let's go back and look at our decompilation and look at how this is doing it. It's always doing, yeah. See how it's pulling off the counter here, .b, bl. Yeah, so it's always going to be doing single byte XORs. So we should be masking off, like, if the counter runs big, it runs big, but we're only going to take a byte of it and use that as our mask. So that's fine. Okay, so that should be, so let's undo. All right, and now we have a bunch of encrypted strings. And now if we rerun Zeus decryptor, we have a bunch of decrypted strings. The nice thing about doing it in place, right, because we could have just logged all of them. This is interesting. So, oh, these are, yeah, there's some other stuff being used here, but now we've got a whole bunch of extra bonus strings. So we not only have them by writing them back to the binary view, like these all show up here now. So like all of these strings here are not in the original binary. You wouldn't actually see these strings in there. But although I'm curious why this split, is that split normally? No, it's just the way the UI is showing them. Yep. So we've got our string decryptor here. And then a bunch of other, yeah, I'm curious. One thing I did notice, oh, and also, by the way, after we've done this as well, in here now, we can see our structure is really clean. Like this is all gray because we made this structure, and we've got string references. And these things all show up as actual strings here now, like where they weren't before if we open refresh again. So, okay, what else? Let's go back and actually see where this string decryptor is used, because I wrote up a previous version of this, and I didn't take it any further than that. I just wrote the little decryptor and I moved on. So what I want to do is, again, this is kind of my like hack of I click the member, and then by double clicking the the root of it is going to go to the top of the array, which is kind of nice. But whereas if I wanted to go to that specific cross-reference, I could hit it over here, right, and go to that one. But back at the root of it, we've got, let's go look at our cross-references again. So we actually want not data references. That's right. So what was it before? Was it just the address versus? No, that's fine. Yeah, if I select the offset as well, I can just get like the code references to the address instead of references to the structure. So here was our function where I really care about. So this is like decrypt string, right? So here's our, it takes a string ID and the destination is the buffer. But what really would be nifty would be now to iterate. Let's look at all of these calls. So they want like string 78, right? See you, Daniel. Yeah, thanks for hanging out. Even though we're on a non-Friday day. So this one here, they want string 7 and they're going to put it in this like decrypt buffer here. What I really want to do is name this variable whatever that lookup is, right? So let's do another one. So now we've already decrypted the strings in place. Now we can literally just look them up directly. Let's have, okay. So let's see, how do I want to start this? Let's have our other snippet. Well, let's just do it once. Let's just write it once real quick here. So what we really want is, do I still have, let's go get that thing I did before. So here's the offset of the table, right? So this, S is equal to that. So start address S. So if I just do bv.get ASCII string at, what I want to give it is, I'm going to take the start address times OX78. I'm just doing it once by hand manually for like whatever the string ID is, that we'll automate it for all of them later. Times 8. All right, but then I want to offset 4. Okay, so that's actually the base pointer. So really, okay, so really I need is this. I need pointer is equal to bv.read int. And then the address is there. There's our address calculation. It's 4 and it's sign equals false. False. Okay. Oh, sorry, it's not a pointer. Yeah, this is not read int. No, hold on, hold on. Print hex value. What am I getting at this? Okay. What is the pointer value here? That's not right. Hold on. What is S again? S. Oh, hold on. That's times 78. That's why. Plus. Yes. That should be right. Okay, so let's read. That's what we're doing wrong. We're going to add that counter. Counter times 8 plus 4. Read 4. That should be a pointer. Positional follows. S equals, no, that's because it's plus. Okay. Now bv.get ASCII string at pointer. Value, not string, yeah, text. Okay, cool. So what I really want to do is I'm going to rename this text / right? And that will dramatically clean up all the code. So what we're going to do is we're going to do fn is equal to get functions by name. Sure, there's only gonna be one. Decrypt string 0. Okay. So let's start writing our snippet now. So snippet editor, new snippet, Zeus 2. Okay. So let's call this D is equal to, there's our string decryptor function. And also let's just save this and open internal external editor. Remember I want to allow untrusted open. I'm fine. Okay, so Zeus 2 is we're gonna walk all the cross references now. So for ref in d dot, I think it's call fn dot call these call sites. No. Dot caller sites. Yes, that's every cross reference, every where this thing is called, right? So I could pull off like the first one, for example, and then get like dot HLIL, and I should get, yes, exactly. Okay, so that's what I wanted. So for reference in d dot caller sites, we're gonna get the variable. Okay, so I have a reference. So if I get the HLAL, I've got the high level AL, but params, no, yeah, params sub 1. Okay, so param sub 1, 0 is going to give me that value. It's going to give me the constant index. Okay, so index is equal to ref.hlal.params sub 0.value.value. I do the value.value because it is a high level AL constant, but the actual just number would be .value. .value. Okay, so that gives me my index. Okay, and now dest var is equal to ref.hlal.params. So 1. And I don't yet know off the top of my head. Can I just do this? Not 1. So this is literally the first cross reference. Oh, and actually, you know what? Before I do value.value, because you notice here, in some of them it's not in some of them it's like a variable. So I only want to continue if this is a constant value. So dot. Actually, let's do this. Yeah, let's see what the parameter is. Okay, is instance constant true. Okay, so if not is instance is not instance of thing, that would be funny. Is that actually is not in? No, didn't think so. Not is instance index constant. Continue. So now I know index is equal to value.value. If it's a HLL constant, I can just get the value out of it and get the regular number. So I've got an index and I've got the destination var, which I keep hitting 2 for that instead of 3. So the destination var is right here is the address of. So how do I get out the i.vars? I can do this. That's fine. .name. Beautiful. So I think, let's just test this. Equals test. So I should see, yes, you saw the change right there, right? So that one just changed to test. So that's the easy way to set the name. So decrypt string is equal to, we've got CR index times 8 plus 4 plus whatever our base of our, oh, we already have it up here, didn't we? Yeah, nope, not in this one. What do we call that? Let's go, we'll do it the right way with a simple name for the base of our, what do we call S? S here was, there we go. So we're gonna give it a better name than S though. We're gonna give it table is equal to that. So there's our table start address, and it's the index times 8 plus 4 plus the base of the table is, that's the pointer to the decrypted string. And let's just do it straight from here. pv.get ASCII value, or ASCII string at, ASCII string at, get ASCII string at that address. There's the variable. So I honestly, I would just try to set it. We'll probably hit some weird like formatting where it's not like invalid characters or something. Let's just try it. Dest var.name is equal to decrypt string. I don't know. Maybe. Let's try it. Let's see what happens. So we're on decrypt string. We'll see all the cross references. So we should see a whole bunch of these make pretty. Let's try it. Zeus 2. Or we'll get a useful error message that will tell us what we're doing wrong. All right. Go to the end. Go to the end. Couldn't see my cursor. Var init has no attribute params. Oh, you know what I'm gonna do? I'm gonna get the MLIL just because I should be able to do the same things, but it's less likely that that is buried in a conditional. Maybe, or maybe it's still gonna be an error. Is it not running? What did I do? I did something wrong. Hold on. MLIL params. That should still work. Well, that should still be fine. Print cross-reference at hex ref.address. Oh, I retyped all those. I already knew them. These two. Okay, yeah. So it found all the cross references. But why are you not with MLIL ref.mlil? I mean, yeah, I see. Oh, it's my is index. Okay, let's add some more printf debugging there. Oh, well, this is a problem. First of all, no, it's not. That's right. That's right. Hold on. Index.value. That was one problem. I don't know if that was what was. Feels like something else is wrong, but that's one problem. Oops. Oh, if my mouse is on the bottom when I mouse wheel, it does that. That's funny. Okay. Hold on. Clear log. So this should give me some, but I should, okay, here. And then actually, if it is constant, let's just print that out. Well, clearly that test is wrong. Yeah, exactly. Let's get all the, okay, so, and by the way, we could extend our script to handle even this case, because where the entry is not constant, it's still almost certainly in the parent functions of that function, there's going to be a bunch of cross references that we could match in. Like anytime it's entry, whatever, we'll just go look at the cross references from that and still propagate that down. But what am I doing wrong? Const is not const. I think what I want to do is, oh, I know what the problem is. If index is not, I think this is what I want to do. Let's YOLO it and let's save it that way. Try it. Hey, okay. Cannot assign to field name. So we're closer. We're closer. Now we're failing to write. Oh, vars. Is it vars 0? Yeah. .var. Okay, hold on. Let's find one. So let's just get this will work. Current IL instruction dot params sub 1. What do you mean there's no high level error to declare? Oh, because I have the wrong line selected, Jordan. You should select the correct line. Params sub 1 dot vars. Yeah. What do you mean there's no vars? params sub1 dot vars. Sub 0. Okay, hold on. There's a better way to do this though. It's not dot vars. Let me get dot. So if I have an address of source operand, source dot name, no, source dot var dot name. Okay. This instance. Source dot var. Okay. I think it's always gonna be true if there is a var that exists. So I don't even know if that's a useful check, but let's see if that works. Okay, so param1 dot source dot var. Sus2. 10 errors. Variable object has no attribute var. Oh, because sometimes we're pointer 2 and sometimes it's a local variable. That's why. Okay, okay. So that makes sense. What we have to do is handle both cases. So, yeah. So, right. If it's already a variable, if is instance, if it's not var variable, so if it's not a variable, but, and has attr dest var dest var equals dest var dot var. Now, if is instance, now if it's a variable, it's probably a cleaner way to do this, but so this way, if it's not already, but if it is already, it should just say, okay, let's see what that does. Oh, it did a bunch of stuff. I don't see it changing any names though, so I'm not liking. Let's see. Let's add some logging here. Okay. Setting name of dest var to decrypt string. Okay, so first of all, yeah, setting it to none, so decrypt string is not right. Well, and I know some of these, okay, so some of these are not actually valid strings, and that's actually expected. But not all of them. Like definitely like OX94. Okay, so something is wrong with my array calculation. I did this earlier. It was the index times, yeah, the index is, okay, so the base of it, we go 4 in, index times 8. That sounds right. So, at offset hex decrypt, no, d offset is equal to I know I'm mixing conventions here, which is just poor form. Okay, so, oh, right. That's okay. I need to read the integer there. Okay, so d offset, pointer offset is that. D offset is equal to bv.read int. I forgot to read the integer at pointer offset and reading 4 and signed equal to false. There we go. And I keep, okay. String reference has no, okay, so it's now decrypt string, what is it, dot value? Yeah, so let's double check that. bb.get ASCII string at here dot value. Yeah, okay. So I was missing a dot value. Just getting a string object. None has no dot value. Oh, right. Okay. That's if decrypt string equals decrypt string dot value. And let's, oops, do all the rest of the stuff. Only if I have an actual ASCII string. If I have a real ASCII string, go look up the, yeah, if I don't have any, I think that's right. Okay, I saw a whole bunch of stuff there. So decrypt string. Did I call it that? No, this is still not making me happy. Okay, hold on. Yeah, this should have worked. Okay, so the string it read, edx1. Yeah. Okay, so something's not right here. Let's actually look at where we're writing here. Dest var from offset at instruction offset x, and we're going to be at ref dot hlil dot address for il ref dot hlil. Oof, that's a lot of debugging we're getting into here. You know what? I need like a faster way to, okay, so yeah, okay, so it should be setting name of data to data. Oh. Well, it means, oh, okay, hold on. No, it is, the variable names are right. Hold on, is this just like a UI is not refreshed view? Hold on. Current IL instruction. Well, actually, you know what? I need to be doing this at medium level. Oh, that was why. Yeah. I did it on medium level IL, but then the variable doesn't necessarily do the same variable at the high level IL. That was exactly the problem. So now if I look at all the cross references, yeah, so these are all shown in high level IL. So really, I should actually just change this. And then a couple of these won't work because they're wrong, but I should just try and handle it, right? So because high level I have to deal with like the nesting of things. Anybody hanging out, man? This has been going long. I think I've lost most y'all. So let's just be lazy here too, and let's look at let's see, if not is instance ref.hl call continue. So if we're not a call, just continue. And if we are, then everything else should work fine because we know we're at the top level, high level IL instruction is a call. Let's see. Oh, I wonder if HLIL vars have different. Maybe when it switched to medium level IL. Yeah, that's why I made that change before to variable types. I made sure it was a variable, but that should still. So let's look here. Let's switch this to high level IL. Here's a bunch of them. These should all work basically. Current IL instruction dot parent. So first of all, is instance, is this a call? Should be. It is. Okay. What is params 1? It should be, it's an address of, but I should be able to get var. Oh, because I can have multiple, it's not dot var, it's var 0. Okay, dot var. So do the same kind of thing. Okay, I think that's just an MLIL versus high level IL difference. I didn't realize that. Has that or attribute, which should be a string. Yes, it does. So if it's not a variable, but it has a dot vars, get the dot vars out. And now if it's a variable, we should be able to do that. Oof, so we get for switching back and forth between medium and high. Hey, oh, look at that. Look at that prettiness. There we go. Cool. So now we've got all of their, all the calls to decrypt buffer. We've replaced the variable with like the decrypted name of the string. Yay. Whew, took me a little while. A lot of little bugs, but awesome. Yeah, so okay, well that's kind of what I wanted to do today. Again, Jordan pretends to be a malware reverser. I'm trying to think, there was a couple other stuff that I was going to look at. Yeah, I was just going to kind of poke around. Like, for example, now I'm seeing this almost looks like an optimized stir comp. This feels like a stir comp. Very nice, very nice, very nice. Cool. I know. See, now I'm just gonna like. It's so hard that once I get hooked on it, I just want to keep going. So if this one is a stir compare or is it a stir copy, because it looks like it like it's not equals 0. So, all right. So this is arg1. We're gonna pull a byte of it off. Yeah. So this is a byte at a time from arg1. ESI minus arg. Oh, that no. So you guys, the byte? No. That doesn't make any sense. This particular line here confuses me. Anyway, I need to stop because I need to go home. But this is tempting. So anyway, yeah, thanks y'all for hanging out that stuck through with me. It's a fun little bit of malware, and I'll get better. Those are kind of similar looking. Interesting. So yeah, that's nice. We've got much more readable code. We could also, by the way, just have made this a little bit easier. Instead of naming the variable, we could have just like added a comment here. You know, for what it meant. But the problem is, it doesn't always line up, right? Because the addresses are the same where the variable's being defined here. And so, and the other problem is that, again, you care about where it's used down here. So if you annotated it up here, so that's why I like renaming the variable itself to whatever the string is. I think it's way easier. And let's go look real quick through all the other cross references here to decrypt string. Let's just see where everything else gets used. Web inject data. Oh. Web inject %d data. Huh. Two and three. And we got a little structure going on here, something more fun. Oh man. Okay. I promise to stop. I promise. Okay, let's get back. There. Okay. All right. I'm gonna resist the lure of more reversing. This is what happened to me last week, as I was supposed to be preparing like a demo of a bunch of stuff, and then I ended up just getting distracted and reverse engineering for for longer than I should have on totally unrelated things. So, oh, and I just missed. There's another one where they're writing out like this batch file script that you can see now too. So, yeah, I like those little scripts. I'll go ahead and post like these to a gist or something so people can, if they want to play with the snippets that I wrote, they don't have to do it by hand. I'll put it as a comment on the stream. So again, yeah, thanks everybody for hanging out. And if you're watching the stream later, don't forget, first of all, thank you for staying with the whole stream. And second of all, don't forget to leave a comment about whether you would prefer lower latency or higher resolution. I think we might compromise. Next week, we'll try 1440 and low, and we'll see how that works. So thanks, username. I appreciate it. That was fun. That's why I got really excited when I was messing with that sample earlier. So I wanted to write up a little bit of scripting stuff. I thought people would enjoy that, and I'm glad y'all did. So Ryan as well, thank you. Yeah, see, people are here. The funny thing is, like, the viewer count was literally like 2 people like 5 seconds ago, but I think as soon as people say something, it knows like, oh, they're still there. So yep, I will be here next week. We'll be back, not this Friday, but next week sometime. Probably back again Friday next week. We'll see. It depends on what my schedule looks like. So, Pizza Boy as well. Yeah, I think, look at this. So many other people just hanging out. Look at y'all. KI. It's hilarious. It literally said there were 2 people here, and then like 7 of y'all have all like, yeah, no, we're here. So awesome. We'll catch y'all next week. Cheers.